We'll want to start the.
All right. I gotta move this.
Thank you for your information.
Yeah. Let me get the share opening. Go. So the screen I'm sharing, you should see, says Chapter 4, T4 Amateur Radio Practices. Is that what you see?
Yeah.
We can see
All
that.
right. Thank you. So this is not the one that was the team had earlier. I grabbed this because it has some graphics at the front, and you previously learned about radio waves traveling and all that. And this is covering station setup and operating controls. There are only going to be 2 questions out of the 24 we'll review that will be in the test, so it's not a large number. And when you get to radio engineering concepts, sorry, it's jumping. I got to grab the slider so it doesn't move so abruptly. Oh, I know what I did. I went too far. T3. I had this trouble last time. Here we go. So shack configuration. The term shack, people think of a broken building. In ham radio, we call our collection of radios that you saw in the background with me the shack. Doesn't mean it's any particular building. It's just where you have your radios. And you can be from itty bitty, the handheld I show you, to more complex, like it was in my background. And the important things are the transmitter receiver. And when you'll hear the term transmitter, is what we will send our radio signals. The receiver could be a separate device, and it receives what we listen to. When we combine the two together, then it is a transceiver. So it's radio equipment for converting users' input and output information to and from radio signals. So remember, trans is a transmitter, receiver is the listening, transceiver is what we call what most of us buy. The antenna, well, you already know that. We send energy up in it, it radiates out as radio frequencies that you hear from wherever you're talking to. Now, here's an example. This is why I brought this one, a collection of things. This looks complicated. You don't really need to memorize any of this because it would vary. But here's the transceiver. This is our transmitter and receiver. And it has an example. If we're running HF radio, not the handheld, we would have an antenna tuner. And you only have to have that if the antenna is not properly adjusted. But most of us have an antenna tuner. Many of our transceivers have an antenna tuner built into them. It's very common. So this is kind of the basic radio: transceiver, an antenna tuner, and an antenna. And you see these things where it goes to ground and a grounding strap from the transceiver to the ground. These are important electrically so we don't shock ourselves, but also it has to do with even the radiated power and how we receive things. They have a regulated power supply. And all that means is, and we'll touch these, electric device to give clean, direct current power to the transceiver and other devices. Because when I can't plug in my outlet, that's 120 volt AC going up and down. Instead, this converts it to DC. And just so you know, DC doesn't mean that it's straight like from a battery. It may have some form, but it's all the same direction from the zero. It's all positive current. It doesn't go negative and alternate back and forth. That's the important part. And this has to be sized appropriate for the device you're using. A microphone, we all know, we're all using one right now. Yours may be built in your camera. Mine is this nice, well, I can't move my camera to show. Sound card is mentioned up here from a computer. There are digital modes that need a sound card from the computer. And let's just leave it and call it a sound card. It's not this card that's in your computer that makes sound like I'm listening to when you talk to me or you listen to me. It is a different device, and there's even a signal interface, another similar device, a modem. Modem, if for those who are young, modem stands for modulate, demodulate. It goes way back to when you hooked up a computer, you took your phone handle and put it in a cradle and it listened in it, converted it, modulated and demodulated audio that was on the phone into what the computer could understand. So these devices, the key is antenna tuner goes between the transceiver and the antenna. That's one of the key ones. Remember, the sound card exists, signal interface. These are things coming from the computer and the monitor. Everything to the left is associated with the computers. And the other parts are the basic radio. So antenna tuner, regulated power, grounding strap. I use a large wire or braided copper. A really wonderful thing is literally a solid strip of copper, like a big ribbon, carries the ground. Earth ground, in my case, and most of us, we drive a stake in the ground if we're can get outside. Mine's an 8-foot stake driven into the ground, and it gives me a good solid connection to the ground. Microphone, well, we're using one. Computer, we all have a modem, supports, as I mentioned, digital modes, text type communications, RTTY. I don't even remember what it stands for always. Most of us say ready. APRS, we say that's a automated position reporting system, I believe. There are a number of things, and the signal interface I mentioned is this little box up here. It's part of using digital systems. Again, sound card, signal interface, and the modem up here are things that are common. So transceiver, you already learned about radio waves. A lot of transceivers support FM, which is frequency modulation, amplitude modulation, AM. We usually will just say FM or AM. Single sideband is very efficient, and we'll say, might say SSB. A lot of us will say, somebody turn their speaker down a little because we're getting feedback loop. Single sideband, most of us will say single sideband, whereas we always just say FM, AM. Single sideband, you'll hear said. Lower sideband is below the carrier frequency, upper sideband above it. Continuous wave, CW. People believe CW means Morse code, and effectively it does, but it really stands for continuous wave. You turn the transmitter on, a signal comes out, you release the key, there's nothing. You press the key, the signal goes out. There's no intelligence embedded in the radio wave. It's simply there or not. And because it's simply a case, can you detect it? It's really efficient. It can get through when you can't hear anything else because all you do is it there? Is it not? It's like a light in the distance. It flickers on, flickers off. That's all you have to have. Main operating display. On your radio, we'll have these visual displays of what you're tuned on. The waterfall, if you're still seeing my screen on the side, you'll see behind me, this is an extra monitor, makes it big for me. But down below that, it looks like water running down. This is low frequency and higher. Here's somebody talking, and it makes it very easy to visually know where I want to tune. It shows the frequencies in the band that I'm used over a short period of time. You got to be able to select what band. Remembering band means like a frequency, we say frequency, but it has a band. So I'm listening to 14.3 megahertz, that's 20 meters. And so you need to understand what band means. Variable frequency oscillator control, that's the tuning knob. I'm spinning my knob, it changes the frequency. Most of us never say variable frequency oscillator, you just say VFO, big knob, tuning knob. And on a lot of radios, because you have memories, it may switch memories when you pre-programmed, but we'll say VFO, and it means variable frequency oscillator. Nice picture of a 20-meter frequency. This is from an ICOM 746. It's this radio that I had that radio at one time. That's not mine, but I love the waterfall display we have. There are other things, automatic gain control, compression, TCN. you can get all these acronyms. You will learn them as time goes on. Don't be intimidated. You'll start learning. There'll be a signal strength meter. When a radio signal comes in, you'll hear people talk about how many S units. It's a signal strength meter. It's quite relative.
Nó bể nó sao mình cán định cái gì giá dùm. Cái đó giá vô xe chắc chạy ra tiệm ly đi.
So the signal strength, it'll tell you how strong the incoming signal is.
Ray, can you
Automatic.
mute that other mic?
Bên đây nó có giá không? Kế
Can you
bên
see
này.
who it is?
Okay.
Yeah, Vu took care of it. So automatic level control.
Okay, thấy rồi nè. Dạ dạ.
Yeah, it's not Vu, it's somebody else. Oh, Vu, can you mute you have a second image. I think your audio is coming out.
Mình làm. Okay, dạ. Rồi.
Can we mute it from
Okay,
here?
dạ, dạ. Cái xe này
Steve, maybe you have privilege. You can mute that second
cái là thay nhớt.
Anh Giác làm ơn tắt cái speaker anh.
Ok rồi. Cho nên ngày mai có rảnh không? Ngày mai được không? Mai tới chiều mai rồi. Dạ chiều mai cũng được mà tại
Anh Giác ơi.
We have an open microphone that's too loud.
Thanks, Anna. He got it.
Got it. So automatic level, it says how much transmitter is adjusting the audio level. It's simply so if I talk really loud, it would reduce it. If I talk gently, it would bring it up. It sets the level of the microphone so it will tolerate a bigger range of differences. Microphone input, you plug it in somewhere. Squelch level. On an on an FM radio, you can turn a knob so it, unless it's when it receives nothing, it turns off the audio entirely. If you turn it so it's no squelch, it just hears static when nobody's talking. So squelching, by the way, means like turning something off. Squelching is a English term that most people don't know, but you can turn off the audio with it. You set it so it's just off, and then if a radio signal comes in, it'll turn the audio on automatically. Receiver incremental tuning on these little handhelds in particular. In my little handheld, when I turn the tuning knob, I might want to go in 2.5 kilohertz steps or 5 or 10 or 25. You can, on many radios, you can adjust the step size. So when you turn the knob, how big a step does it take? Audio output volume, that's the volume knob. We all got those. Memory keys to recall pre-saved. We do that in our car radio. We press number 4 and we get, if you're in the Bay Area, you listen to KGO. You probably don't. I don't know if they're on FM. AM's kind of almost gone. Control functions. Think of controls, soft keys do pre-configuring things. They may be function keys where you press this and do this. They're the keys that do more complex. Cabling. I have a real mess of cable behind radios between the transmitter, the amplifier, the tuner. I can bypass things. I have some antenna switches. It makes me configuring, but all this cabling, it connects several things. One are RF connectors. They carry radio signals to and from the antenna and the transmitter receiver. Microphone connectors, maybe a plug that's a round plug, or many of them today are look like I don't know which way mine is. Many of them now are, get it close enough, look like a telephone jack. They vary in style from a round pin to things like telephone jacks. Audio connectors, maybe a plug-in. It can be wires that go on a stud. I have a separate speaker I use for one-way radios because I like the audio better. Data connectors. These you can have Bluetooth, Wi-Fi. I have USB connectors. The USB is your standard computer cords. We plug in the little flat things, and there's some that are the USB-C or the FireWire like Apple has. I have to connect my computer for digital work. I just have a USB cable. It depends on the device you're using. Digital mode software interfaces. There are a bunch of these. I mentioned APRS is Automatic Packet Reporting System. I was thinking position. It's packet-based. Packet means when you send data, you send a little, a cupful, a packet full. We send it in chunklets, and then we may get some signal coming back saying I got it correctly, and I send another chunklet. That's a packet. So you don't just stream it like television on the air. You send chunklets, hence packets of data. Radio teletype, ready, as I call it, RTTY, PSK31. They're modes that are for sending text messages. These are digital. FT8 is very popular right now. Character-based, very short messages. FT8 for most people is a cute, interesting digital mode. I can do things online and watch where my radio signal goes around the world, and all you do is say hi. You don't even say it. It's pre-programmed. Here's my call sign. I heard you. Here's how good my radio heard you. Bye. That's kind of it. And some people love it because you can make a lot of contacts. I'm not passionate about it because you're not really communicating. It's just a simple check. CW, we said, sending and receiving Morse code. A gentleman I was listening to the radio knew who I was when I called. He was running some logging software on probably a laptop. He typed my call sign in and said, hi, you're Dan in Seattle. So there are all these extras. We mentioned the cables. You can't really see this, but be aware. These terms BNC, SMA, UHF, PL259. You'll hear these and you will learn about them as you use them. The BNC's kind of gone. ICOM uses it in one. SMA is a style that's popular on the top of the most handhelds today. The PL259s really is common. It's called UHF. People use it for HF radio. That's what I'm running out of mine. And F connectors, that's your television, connects into the cable thing in the wall if you have that. Microphone connectors, we mentioned there are a variety. Mini pins, some look like telephone cables. RCA jacks, these tend to be audio. Microphones plug in with these, speakers plug in, a normal collection. And then the multi-pin, these look for your computer. USB connectors, you're aware of all these. Just be aware there are a lot that exist. You got to make sure you get the right kind. I'm not going to go through this. They talk about what they mention a TNC, a terminal node controller. Not many people use equipment that require this. It had to do with digital communication from between the computer and the radio. Now, station setup. This really jumps. Here we go. So station setup, this whole group, they're showing where you're doing digital things. Computer, connectors through to a transceiver, or you may have this signal interface box. I run something like this. Mine's a really simple box. There's no knobs on it. But the transceiver, the radio's over here. This is computer. Just a number of ways to connect, and every one is a little bit different. So here are the questions. And some of this you may have to reach out for. What's the appropriate power supply rating for a typical 50-watt radio? And that's one, like I showed you, if you've seen my picture, belongs in a car typically, 25 to 60 watts. And the answer it discusses is, in a car, we typically use 13.8 volts. We say 12 volts, but cars really are set up for 13.8 volts. And that's the first thing here. And then the amperage, 4 amps or 12 amps. I have, Steve, have they had learned about amps and voltage and power?
We've had T2 and T3 so far.
So not really.
Yeah, I don't believe so.
So that's where this question seems out of place. Amperage is how much water is going through the pipe, how much current. Voltage is how hard you push the current. And 13.8 is what most of these radios are running on typically. And 50 watts, if you multiply voltage times amps, you get watts. Well, 13.8 times 4 is a little more than 50, and you might think that's appropriate since it's 50-watt output. This, though, is 50 watts of radiated power, of radio power going out, and a lot of power is lost in the device itself. In fact, my radio I showed had those ribs for cooling. If I transmit constantly, it gets really hot. So the reality is 50 watts of it goes out, but there's a lot of overhead, other processes, power loss in the radio. That's why your only choice is 12 amps. I measured one of my radios when I key up using voice, and about 50 watts, I'm running about 8 amps. It's way more than the 4. So the only answer here is 12 amps, because that 50 is not enough. Which following should be considered when, oops, I hate how this jumps. Which of the following should be considered when selecting an accessory SWR meter? Now, you talked about radio waves already, I know, and SWR is standing wave ratio. And you're trying, and let me read the answers. The frequency and power level at which the measurements will be made. It's not how far away, it's not what kind, it's just about the frequency and the power. That said, some radios, they're built in. I have a separate meter I can use, and I have to make sure if it's only designed to handle 100 watts and I plug in my big amplifier and put 1,000 watts, it'll burn it up. So you got to watch out how much power you put in, and they're designed for particular frequencies. I might buy one that works for my handheld for the 2 meter, 70 centimeter, need a different one for the high frequencies, which are much longer waves. So you have to buy one for the appropriate frequency and power level. The main thing I'm trying to get across is why we use the answer we're giving here. So here's why are short, heavy gauge wires used for a transceiver? So remember the transmitter part, DC power connection. And the reason is going to be to minimize voltage drop while transmitting. And because we've not covered this in the sections you've had, but if you had a straw and you have a little skinny straw like a stirring coffee with, and you try to drink your soda, you'd suck really hard and not much would come through. You'd have to have something pumping it like a pressure washer at high pressure. Well, that'd be voltage. So to let more through, we use a bigger straw. We use heavier gauge wire because we're going to run off amperage, which is the volume of the electricity, the amperage. We need heavier gauge wire. Shorter is better, longer we have loss. So short, heavy minimizes the voltage drop. If it's too skinny, it just doesn't get through, the voltage falls off. How are the transceiver audio input connected in a station configured or operate using FT8? Remember, we talked about it's one of these digital modes, and they say a program called WSJTX. I have it installed. I do not remember what it stands for, but it's what I use for FT8. And I connect it to the audio input and output of a computer running the software. That's the key. It is an audio set thing going to the radio. Now, in my case, I have a sound card. I can connect using my USB cables. I don't actually plug into a speaker, but you have to connect through the audio input output of computer running this. It's kind of a tough one because it's not quite intuitive, but it's not, a conversion unit. It's not converter.com. It's not a program. And it's not about a terminal program connected to TNC. It's audio. It's an audio input and output system. Where should an RF power meter be installed? Well, we want to know how much power is going to the antenna. So we put it between the antenna and the transmitter, the transceiver, in other words. Power we transmit, it goes to this thing. It'll show us how much power we're putting out. And that's all we care about. If I have an amplifier, I would have that meter after my amplifier. It's really to see what goes up the feed line between the transmitter and the antenna. So there's the A answer. In the feed line between the transmitter and antenna. Picture transceiver, the meter, the antenna. Which following connections made between a computer and a transceiver to use computer software when operating in digital modes? And up above, there was a diagram. And here it's like computer, I got to read this. Computer line out. I'm going to go up and show this to you. Here they have a transmit to the receiver, a receive, and a control. So we go back, and the same thing here, regardless of what connections. We'll go back to that question. This is one that's absolutely not my favorite. So we're going to go from the computer line in to transceiver speaker connection. Done. This one can be a hard one because you have to read each of these answers to see if it makes sense. And it's simply computer line in to transceiver speaker connection. It's really, I think it's a poor question. Which of the following conductors preferred for bonding at the RF? Bonding in this term means connecting solidly where the RF goes. The antennas, for example, and an excellent RF ground, we made low inductance, high current, means a nice big chunk of copper. And they want D, flat copper strap. I'm using a copper braid, but not removed from it. It's meant for grounding. But the answer you're looking for is flat copper strap for an excellent RF ground bond. How can you determine the length of time that equipment can be powered from a battery? Again, this comes down to the voltage and amperage. And so you've not covered this. But if I'm going to read this answer, the measurement units for quantities tell us how to answer it. We measure the energy stored in the batteries in amp hours. In other words, a battery could supply, say, 1 amp steady state for 10 hours. It would have 10 amp hours in it. 2 amps for 5 hours also would be 2 amp hours. We measure the current drawn in those amps. To find the time, we divide the storage amp hours, how big the battery is, by how much we're going to use. And so you divide the battery amp hour rating by the average current draw. The current is the amperage. Remember, current, amperage, same thing. Amperes is the unit. Draw of equipment. So just as I said, if I have a radio that draws 2 amps, I have a 10 amp hour battery, it could run for 5 hours. Remembering, it's not mentioned here, that batteries don't supply voltage steady. Generally, they go along and start giving less and less, like your car battery dying. It tapers down. Some batteries stay very stable a long way and then go kerchunk and die. But you don't get all the power. When you look at amp hours, it's rare to get all that power out. It's not often many batteries, it's very bad for the battery. What function is performed with a transceiver in a digital mode hotspot? And you're going, what's a hotspot? If you can see, here is a hotspot. It's a little baby Raspberry Pi based system. And in this case, I have a receiver built into this. I can talk to it in my handheld, and it can then connect to the internet and send signals wherever around the world I want via the internet. So it's going to communicate using digital voice or data systems via the internet. And it's useful when in my home here, I may want to talk on a net that's not even in Seattle, and I can't talk directly with a handheld. I can talk to this. Some of these you can actually have a microphone connect directly, but it is communicating in digital voice or data systems via the internet. Very popular. People on our local machines here, we get guests coming from around the world on our just routine daily chit chats. And they get called a hotspot, and there are many brands. Where should the negative power return of a mobile transceiver be connected in a vehicle? And the answer they want is A, at the 12-volt battery chassis ground. And what that is when I connect a radio, I have power coming from the battery, the 12-volt, the red one, the positive. Cars are all negative ground, except really old Volkswagens. And I could connect to anything that connects to ground. My preference is to go all the way back to an extremely solid ground. When you have body work, metal parts, they may connect electrically, but if they're not really connected well, you might use too much electricity and have resistance there. So I go clear back to the battery, but at the 12-volt battery chassis ground. It's the same spot if you look in your car. It's hard to see in a modern car. The black cable comes off the battery and goes somewhere nearby and is bolted to the body. That's your chassis ground. So you're trying to get it back so the power goes back as close to the battery as it can be, and it's connected to the most solid connection, the chassis ground. Your mobile rig needs, what is an electronic keyer? Oh, let me go back up. Can I get this one to show? What is electronic keyer? It is a device that assists in manually sending Morse code. I've got one behind me with Morse code. Instead of having a key, I actually have all the examples I could show you, but instead of going dot it, did and pressing and holding, electronic keyer is a separate device or built into the radio. And in my case, I use one where one button goes da da da, that it was did it, and it's called electronic keyer. A lot of people use it. You don't have to, and it is for assistant sending manual Morse code. Now we get into operating controls, which is really a pretty quick one to cover too. Transceiver controls, for we already talked about these, basically filters, noise blanking, digital transceiver configuration. We'll just go through the questions. What's the effect of excess microphone gain on single sideband? And just like you'd expect, it's like shouting into a microphone. You get distorted sound, distorted transmitted audio, and it just will not sound right. Good audio means not too loud, too soft, and what you can imagine, if there's a wave of your frequency of your voice, if you go too loud, it goes up and then kind of gets stuck until it comes down, and that's called clipping. Speakers can do it; they just sound wrong, and you'll get distorted transmitted audio if you have too much microphone gain. That's the volume setting. Microphone gain, think of it as the volume setting for a microphone. And which of the following can be used to enter a transceiver's operating frequency? And when we talk about keypad, VFO, knob, CTS, these are subaudible tones, and tones like telephone make. That's not it. Automatic frequency control, that doesn't, that's automatic. So it leaves keypad or VFO. And keypad, on some radios, you literally enter like 146.960 is a repeater I use. I can enter it that way, or I can twist a knob, and the knob would be the VFO. So just keypad or VFO is what you adjust frequency with. Let me make sure I was not skipping. Boy, I wish this was smooth. Which of the following can be used? We did that one. One more. There's the jump. How is squelch adjusted so a weak FM signal can be heard? Well, we mentioned when we talked about squelch, it's for adjusting, in particular, FM signals. Weak ones may not trigger it. And I mentioned you set it so it's just keeping it from being steady state, like just noise with nothing coming in. You want to set the squelch in the threshold so the receiver audio output is on all the time. Then you'll hear it entirely. So that's where we hit A. You set it so it's just open. It's called open squelch. If you turn it a bunch, it'll turn it off. And so there's no audio at all. So setting the squelch threshold so the receiver output is audio is on all the time. You'll hear the faint ones. It gets to the point you may hear it, can't tell what they're saying. So what's a quick way to enable access to favorite frequency or channel on your transmitter? And well, this is a giveaway. Frequency or channel, well, channel infers a particular spot stored in memory channel. Answer is here and here. You put in a channel. So I don't do that on my HF radio. I have a few stored that I want to go to regularly. Normally I turn the knob and go up and down. But just like in your car, you may have a favorite radio station. You've stored it in a memory channel, you press the button. Sometimes you turn the knob or scan up and down. But storing memory channel, quick access. And just so you know what these are, VOX, V-O-X, would stand for voice operated transmitter or transmission. And it means the radio talks when you talk. It's listening for a sound, and the moment you hear sound, it turns on the transmitter. You probably remember in Apollo 13, the movie, the astronauts were saying something, and Mission Control says, "Is your Vox on?" Because when they were talking and getting angry, it was being transmitted. They didn't have to press a button. Most people don't use it a lot. What does the scanning function of an FM transmitter, a transceiver, do? And answer is C, tunes through a range of frequencies to check activity. And that's a kind of a trick, because I can have a scanner that tunes all my memory channels, or I can say tune from 146.3 to 146.4. A couple ways for a scanning function, and it doesn't have to be an FM transceiver. It could be an HF transceiver, but it tunes through a range of frequencies to check for activity. So particularly imagine something that's channelized like marine radios. I might say, scan all the channels. When you hear one, stop and let me listen. That's what it's for. Scroll on down. Which of the following controls could be used if the voice pitch of a single sideband signal returning to your CQ call? CQ, by the way, is a call you make on the radio. If I pick up my microphone and I just want somebody to answer, I don't care who, I can say, CQ, CQ, CQ. This is Whiskey 7 Oscar Hotel, CQ, CQ, CQ. And people listening and finding me, remember, they might be turning the knob and looking for me, would then respond. It's just saying, calling all stations. And what they're looking for is the receiver, RIT, or clarifier. And what these things do are, if I'm transmitting on one frequency and somebody answers back and it's a little bit off, I might want to tune my radio and clear it up. The problem is modern radios don't have an issue with this, but older radios weren't as perfect on their frequencies. So I might transmit in one frequency, somebody answer me 10 kilohertz away. I could turn a knob called the RIT or clarifier, and it would change how my radio is listening. So it's listening to them, but leaves me transmitting where I wanted to. And it had to do with they weren't exactly all correct. Again, not much of an issue. Can't tell you when I last used it. These radios have it. I haven't needed it. What does DMR code plug contain? And digital mobile radio is a common protocol. A lot of it came out of Europe and Germany. It's used in all kinds of things. And there are many styles of it, but there are some ham versions. And we have to put in the code plug is simply a bunch of access information for repeaters and talk groups. Those are things. So you can connect into many different repeaters from one radio site. Again, I have DMR radios. I don't use them much. They are very popular though. And when you first get into it, it'll be very confusing. But remember, it stores information about access information for repeaters and talk groups. Talk groups meaning I can get on a DMR radio and there may be a group called Middle West, and it's people that are in the Midwest wanting to talk, but I can talk from here and it kind of clusters people in common interest groups. That's what talk groups amount to. What's the advantage of having multiple receive bandwidth choices on the multi-mode transceiver? Well, you already mentioned you got voice, CW, digital, via AM or FM, and by having bandwidth selection prevents noise or interference reduction by selecting a bandwidth matching the mode. CW can take up a little tiny bit, like 3 kilohertz. Wide FM takes 25 kilohertz. And you want to set the bandwidth to match the kind of signal you're using. AM radio is like blathering all over the place. Traditional broadcast is huge and wide. And the waterfalls, well, if you get to see a radio with a waterfall, you can literally see what the bandwidth represents. So it prevents noise and interference reduction by selecting a bandwidth matching the mode. They mention all these modes. Which of the following receiver filter bandwidth provides the best signal to noise ratio for single sideband? And I just said SSB, single sideband reception. And they're saying the answer is 24 kilohertz. And this is one just for you to remember. 500 hertz is an option, is common for Morse code for CW. Dual sideband, which is really unusual. 2400 kilohertz is what you want for a single sideband. This is one to memorize. Single sideband, 2400 kilohertz. Which of the following must be programmed into a D-Star digital transceiver before transmitting? Well, again, this is a digital mode. One of these radios I showed you was a D-Star radio. It's a protocol that came out of Japan used by ICOM. Yaesu came up with and called Fusion or C4FM. They're all related but slightly different. And digital smart technology for amateur radio, D-Star. It needs to know who you are. Your call sign has to be programmed in. Your output power, these aren't having to do. D-Star needs to know your call sign. You actually have to do some registration things beforehand. What's the result of tuning an FM receiver above or below a signal's frequency? Well, distortion of audio signal. We already talked about signals where they were transmitted not where we were. We adjusted to receive it. Same thing. If we're tuning and we're not right where we belong, the signal coming will sound distorted. So these don't describe audio changes in audio pitch. Doesn't happen. Sideband inversion, that's left, right, up or down, have nothing to do with heterodyne tones. Heterodyne is part of how radios receive, except new solid software-defined ones, but none of this has to do with this question. So it's distortion of the signal's audio. Those are the 24 questions. You'll get 2 of those in your test. I'm going to stop sharing. Now's the time for any questions. Any thoughts from anybody? Bueller? Is anybody still here? I see Catherine and Steve's here. Is my audio working? I don't even know now. Looks like Anna's there.
Yeah, I'm still here.
Okay.
I'm multitasking.
It's all right.
Asking us?
Yeah, any questions?
No, we don't. Thank you.
No, I
we don't
like
want to be trust.
I like seeing people.
Okay, okay.
No questions? Any
No,
questions?
still we're going to have 1 unit for homes.
Do you have? I hear sir an arm. Are you waving or have a question back there? Maybe he's waving. Any questions about these things you heard about last week or the week before?
Yeah.
Oh, my question is, my question is earlier you mentioned about the telecom packet that you introduced me.
I mentioned.
Would you send?
I mentioned.
Would you send me the links?
I don't have links to send here today. We're talking about the packet radio or which?
Yes.
No, packet radio is just it's the concept that data is sent in like in an envelope. It's like sending a note. You send it in, you don't send a continuous message like water down a stream. You bring them a bucket of water and then a bucket of water. So data is sent in packets rather than continuously. Packet radio is the concept, and a lot of what we do is packet, even on a computer. There's a lot of interchange. It's not streaming and like television, it's broadcast. It comes at you. If you don't catch it, it's gone. With packet, you can send a bit of data. There are processes to verify it's good that you get back. Then you send the next piece. So it's just the concept of what packet radio is, because we think of packet as a folder, a envelope, or suitcase, but it's the concept that data goes in small packages. Anybody else? Steve, you want to do anything?